This is going to be over the solving the systems of nonlinear equations. These are going to be the monitoring progress problems on page 528 in our book. I'm going to go over, I think, all of the substitution ones in this video, and then I'll probably make another video for the elimination, just so we're comfortable with it. I'm hoping that we're doing good with the graphing one. Obviously, you have Desmos available to you, but we should be able to graph quadratics and straight lines at that on the same time on the same coordinate plane. And obviously, wherever they intersect is where we are going to have those solutions that we're looking for. So we will have no solution, one solution, or two solutions. That's what we're looking for right now. And those are the options that we're dealing with. Now, I understand that some of us are struggling with this a lot, but once we walk through some of them, I'm hoping that you'll feel a little bit more confident. If we need more help, I uploaded also the guided practice that would have been in your notes if we were in school today. And we can go over some of those problems as well. So we're going to start with the monitoring progress though. So if you want to be in your book, it's 528. I'll write out the problems, of course, and we'll go through them step by step. So this is number 4. We have two equations here, y equals 9 and y equals x squared plus 9. So what they want us to do when we are doing substitution is we are going to find something to substitute in for the other variable. Well, they made it so easy for us because in this first one right here, it's y equals 9, okay? So we're going to set these up equal to each other right now. So we're going to say where this y equals 9, we're going to plug that in right there for this y. Okay, so we're going to have 9 equals x squared plus 9. Okay, now our goal here is to get our variable by itself, and our variable that we have is x. Right now it's in the form of x squared, but we've been looking at quadratics, and we understand how to take the square root of things to undo that exponent. So we are going to subtract 9 from both sides, and we're going to have 0 equals x squared. Now to get rid of that squared, we're going to take the square root of both sides, and we're just going to have x equals 0. Well, this means that there's only one solution because we don't have a positive 0 or a negative 0. It's just 0. So what we're going to do is typically we would just plug this 0. Let's change our color so you know what I'm talking about. We would plug this 0 in for x up here. But they already gave us a huge hint right here that y equals 9. So since they're already stating the fact that y equals 9, we don't have to do any more math, okay? We are allowed just to utilize that and say that our solution is going to be 0, 9. Now, if we didn't have something as simple as saying that y equals 9, like we do right here, what we would do is we would take the 0 and we would plug it into the other equation. So we would have y equals 0 squared plus 9. Well, obviously 0 squared is 0. Adding 9, y equals 9. We're going to substitute that back into the equation to figure out our answer. All right, now that was an easy one. That's how they always warm us up, right? Get to the easy ones. All right, let's try a little bit more difficult one. Let's see, let's change colors here. This is number 5 on our monitoring progress again. And we have y equals negative 5x. And they also give us the equation y equals x squared minus 3x minus 3. Yep, that's what it is. All right, so again, we are going to start substituting. So they're telling us right here that y equals negative 5x. So in this equation, anywhere that we see y over here, we're going to put negative 5x in, okay, which really means we're setting it up equal to one another. So negative 5x, oopsies, equals x squared minus 3x minus 3. All right, well, I need to combine all of my like terms so I can start solving this, okay? So that means that I'm going to move this 5x over, or the negative 5x over, to be with the rest of the equation. So I'm going to add 5x to each side. And that's going to leave me with 0 equals x squared plus 2x minus 3. Now we need to take a look at this. Since we still have an x and we still have an x squared, we have a couple of different options. One, we can see if this is factorable. Is there any way that we can factor this easily to see if that'll be an easy way for us to solve it. If we have something that's not easily factorable and you just can't think of the factors, that's when we're going to go back into the quadratic equation. That's the negative b plus or minus the square root of b squared minus 4ac all over 2a. Yes, that is where we're at with it, okay? So let's first take a look at it. All right, so we've got negative 3. Let's double check to see if we can factor it. We need the factors of negative 3 that their sum is going to equal 2. All right, so we've got negative 3 and 1. That's going to give us negative 2. Well, right there we know, okay, let's flip this around. What about 3 and negative 1? That's going to give us positive 2. That right there, that's the money. Those are what we're looking for, okay? Okay, so since we know how to factor and we're pretty darn good at it, let me scroll and give us some more room here. We know that we're going to have 0 equals x plus 3 times x minus 1. Okay, and since we have an equal sign there, we are going to set both of these equal to 0. So 0 equals x plus 3 and 0 equals x minus 1. And we're going to find out that negative 3 equals x and 1 equals x. 1 equals x. All right, now we have two solutions. So that means that we have to take both of these and we have to plug them back into one of the equations. And we're going to get two different y values. Okay, so let's just do it with the first one. Let's look at what our original equations were. Let's change what's going on over here. Okay, y equals negative 5x. That's easy peasy. We got this one. So if we have y equals negative 5x, and we said that right here, x equals negative 3, we're going to have y equals negative 5 times negative 3, which means y equals positive 15. Our solution when x is negative 3 is y equals 15. So that particular point that we're talking about right now as one solution is going to be negative 3, 15. Now let's do it again over here with the other solution that we got. So we have that x equals 1. So again, y equals negative 5x. Let's plug in 1 everywhere we see x. So negative 5 times 1, we've got y equals negative 5. So our next solution is going to be when x is 1, y is negative 5. All right, so that's just an example of how it is when we can factor. All right, factoring, sometimes it's easier, sometimes it's more difficult, especially if we don't remember it. But just remember, it's factoring like we always have been. And some of us are at the point where we could see that right away without having to do this extra step over here with the table. But those are our two solutions. If you wanted to check yourself in Desmos, obviously feel free to. But you're going to see that those are the points where those two graphs intersect one another. All right, we've got one more example here that they give us in our monitoring progress, and this is example number 6. And they give us the equations. Y equals negative 3x squared plus 2x plus 1. Then they also give us y equals 5 minus 3x. Well, I'll tell you right now that this is going to be the one that if we have any solutions that I'm plugging and chugging in, because that's a lot easier for me than dealing with the other ones. So I'm going to try to remember that as we go through here. All right, so, and again, we're doing substitution. So anywhere that I see a y, I'm going to substitute in this 5 minus 3x. So when I rewrite my equation, I'm going to have 5 minus 3x equals negative 3x squared plus 2x plus 1. Now, I need to get everything from the left side, and I want to move it over to the right side. Or if you're happy with putting everything to the right side to the left side, you've got options. It's your choice. You just have to have this all set equal to 0. That is our goal. So we can see 1 if we can factor it, and 2 if we have any solutions. All right, so I am going to go ahead and subtract this 5 from both sides. And I'm going to add this 3x to both sides. I'm doing it in one step here just because I write huge. You guys know that. But we're at the point, I think, in our mathematical careers that we should be able to do that. But please continue to write it out. And if you're not comfortable doing that, then take the time to do each step, okay? So 5 minus 5 is 0, and negative 3x plus 3x is 0. So we're left with 0 on this side, which is good because that's what our goal is. Negative 3x squared, so we didn't do anything with it. 2x plus 3x gives us 5x. And 1 minus 5 is going to give us negative 4. All right, now, well, we see it. I've been factoring a long time. I don't necessarily think that this is easily factorable by whole integers. We know that we would have positive 12 because we would multiply negative 3 and negative 4 together. So we would need the factors of positive 12, that their sum would be 5. And I'll be honest, I just don't see it. We've got 1 and 12. We've got 2 and 6. We've got 3 and 4. That's all we have. This is not factorable by whole integers. So that means that we get to use our quadratic equation. Look at us go. All right, so as a reminder, you will always have your quadratic equation given to you on your formula sheet for any of your state exams. But it is negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and we know that a is going to be negative 3, b is going to equal 5, and c is going to equal negative 4. Now, first thing first, before we give ourselves all that headache, is we need to talk about our discriminant. We need to figure this out right here. So if we figure out that our discriminant is greater than 0, we know that we have more than one solution. If it is 0, we only have one solution, and if it is less than 0, there are no solutions. So let's start there first. That's going to make our life a little bit easier, hopefully. At least we'll know that we're on the right step. So if we have b squared, which would give, oops, that's still highlighter, no bueno. Okay, 5 squared minus 4 times negative 3 times negative 4. Okay, again, this is just our discriminant, so I guess it's a good thing I highlighted that. We'll just say that was part of my strategic plan, right? Okay, here we go. All right, so 5 squared, we all should be capable of knowing that that is 25 by this point in our career. We've got negative 4 times negative 3, that's positive 12, times negative 4, that's going to give us negative 48. All right, 25 minus 48 is going to give us negative 23. Can we take the square root of a negative number? Because remember, this is our discriminant. This is underneath this radical sign. I am hoping that you answered no. We cannot take the square root of a negative number. Okay, there just isn't one available to us. We can't do it. So no solutions is going to be this answer right there. You can stop your math. All right, so this is just 3 examples that we have of using substitution. We're substituting one value for y into the other one, which really means in this particular case that we're setting y up, we're setting the 2 equations equal to one another because y is isolated in each example here. And then we're going to go ahead and either factor it, or we are going to use our quadratic equation, or in simple terms, we can just go through and solve it and just plug it back in. When we're finding the square root of something, it's a 0, and they give us some information. So again, I'm hoping that all of this makes a little bit more sense. If not, please email me, message me, reach out to me on Remind. You guys are killing it with this. I'm really proud of you guys for pushing through. I know it's something new for all of us, but I really do want to make sure that you guys are confident in what you guys know. Yeah, reach out for anything. I am here for you, and we will continue with elimination in the next video. I'll talk to you guys later.